So now we're going to take a look at section 6B, part 2, variance and standard deviation. We've actually already looked at some variance already in the last section whenever we looked at the 5-number summary as well as the range. And like I said before, the range doesn't tell us too terribly much. 5-number summary starts to tell us a little bit more, and we're moving in today into standard deviation, which is probably the most telling of your data. Standard deviation tells you basically how close your data is to the mean. And the mean obviously is your average. So for example, if you think about, me, for example, as a teacher, and I look at class average on a test. Class average on the test is, let's say, an 80. And I look over and I see, okay, the standard deviation was 5 points. That 5 points then tells me, okay, there are some students that are scoring at 85. The class average is at 80. Some students are scoring at 85, 90, 95. Some are scoring lower at 75, 70, 65. Compare that to a data set, though, where the class average was an 80 and the standard deviation was 20 points. Then there's a lot more variation then in my grades, because once my standard deviation goes up, my grades get wider and wider, and there's less consistency. So a big word that you'll hear me when I talk about standard deviation is the word consistency. How close are you to the mean? Is your data tight, or is it really spread out? Ultimately, your goal with standard deviation is or as far as it being able to tell you a whole lot, is if the standard deviation is really small, then this tells you your data is really tight and close and consistent to one another. Try to give you a visual representation here in this first example, and then I'll move into the next page, which will give us a concrete example, and I think from there you should be good to go. So with this section, in example 1, it says, well, let's suppose that the average shoe size in the class is a 7, and the standard deviation then is 1 shoe size. Let's talk about then what's the spread of this particular data in terms of my standard deviations above and below the mean. We're only going to look at 3 standard deviations above and below the mean, and I'll talk about more in the next section of why we only talk about 3 above and 3 below, but nonetheless, that's why we're stopping here with 3, and then I'll give you a mathematical reason in the next section of why do we only look at 3. So like I said, just give you a visual here. All right, so I'm going to put my average shoe size there in the center, and then I'm going to look at 3 standard deviations above. So I'm going to say, okay, 1, 2, 3 standard deviations above, and 1, 2, 3 standard deviations below. And since the standard deviation was 1 shoe size, then 1 standard deviation above the mean would be a shoe size of an 8. 2 standard deviations above would be a shoe size of 9. And then 3 standard deviations would be a size of 10, just adding 1. And then if you go below the mean, you'll just subtract 1, so a size 6, a size 5, or a size 4. Okay? You could do a nice throwback from the previous section, and we could find the range, and we could say, okay, well here the range would be highest data point minus lowest data point. Okay, so 6 shoe sizes. Let me put SS, 6 shoe sizes there. Okay, let's compare that now with, let's say, okay, well now here's my class. This class average shoe size is still a 7, but let's change the standard deviation to 2 shoe sizes. So I'm still going to plot my average there in the center, my mean. I'm going to do 3 standard deviations above and 3 below. And since a standard deviation this time is 2 shoe sizes, then 1 standard deviation above would be a size 9, because I'm adding 2 this time because my standard deviation is 2 shoe sizes. Add 2 more, a size 11, that'd be 2 standard deviations above. 3 standard deviations would be above would be to add 2 more, so a size 13. Go in reverse, subtract 2, so a size 5, a size 3, a size 1. You can compare this now to the range of this data set, and we have 13 minus 1, which gives me 12 shoe sizes. So hopefully automatically you can already see that up here in this top example, my standard deviation is smaller, my data is a lot closer together. Hence you can see that from the range itself. Versus down here, once my standard deviation got a little higher, my data now is more spread out and twice as big at this point. So what I want you to gain from this at the moment is that a Lower standard deviation reflects more consistency, as you saw from the top example. Having that lower standard deviation, I'm much more consistent. My data is much closer. From 4 and 10 are much closer to 7 than in my lower example. 1 and 13 are much further away to 7. And so a lower standard deviation reflects more consistency, therefore less deviation from the mean, while a higher standard deviation reflects less consistency, more deviation from the mean. Okay. Data points that are close together, hopefully it just sort of makes sense to you now. If your data points are really close together, you're going to have a small standard deviation. The data points that have a larger spread are going to give you a larger standard deviation. Clearly, if you have large outliers, that's definitely going to affect your standard deviation. There is some notation that you'll see in this section, so let me go ahead and put that down for you. Sample mean, you've seen this already, X bar, okay, that's just your average. Population mean, though, is mu, and it's just kind of like a cursive M, okay. Standard deviation for the sample is just lowercase s. A population standard deviation, though, is sigma, lowercase Greek symbol, okay. It's not, I'm just going to use these symbols. It's not a big deal that whether you know whether it's population or sample, but for those of you that plan to take statistics, I wanted to go ahead and give you the difference between the two. This is the formula for standard deviation. I know it probably looks a lot of, very intimidating at the moment, but just so you know, I'm going to break this down, put it in a table for you to make it very, extremely doable for you. Here, you've seen this symbol before. It's the summation of your x minus x bars squared, all divided by n minus 1. Remember, n is just the total number of data points that you have. X is a single data point. X bar is just the mean of your data points, your average. And like I said, I'm going to put all this in a table to help us get through it. So let's flip over to the next page, and I'll show you an example here where we'll go top to bottom, finding our standard deviation. In example 2, it says this represents the number of times 6 people went to the ATM in the month of November. So we're saying, for example, one person went 5 times, another person went 8 times, and so on. So what I've done here is that here's what your table is going to look like. You're going to have your data in a column. X minus X bar will be a column. X minus X bar squared will be another column. The first thing that you should always find, always, is X bar, which is the average. So always find that first. And in this case, you just add up your data. So if you added up these numbers right here, if you added that up, you'd find that would to be 57. Divide by the number of data points, and there are 6 people there. So 57 divided by 6, and we get 9.5. That is my standard, that's my average. I don't want to do any rounding there. I want to keep that as close to the number that I have as possible. So 9.5 I will keep. Now I'm ready to go to my table to start calculating the standard deviation. The first column says do your X minus X bar. X is your data point, which is whichever row you're in, minus X bar, which is what you just found. So I'll show some work here. So in that first line, I would do 5 minus 9.5. And then that's going to give me negative 4.5. Next row, I would have 8, data point minus 9.5. And that's going to subtract out and give me negative 1.5. Next one, 9 minus 9.5. That will give me negative 0.5. 10 minus 9.5. That's going to give me 0.5. You would keep on, I'm not going to keep writing this, and I would do 12 minus 9.5, which will give me 2.5. And then 13 minus 9.5 will give me 3.5. You want to add that column down. So after adding that column down, you should get 0. That column should always be 0. If you don't get 0 there, you've done something wrong. And probably the only way that you wouldn't get 0 there is maybe if once you found your sometimes whenever you find your average, it's not a perfect number. I try to steer clear of examples like that in class because I want it to be, nicer numbers for you to work with. But, in real world life, sometimes our data is not perfect. And so you do end up having to do a little bit of rounding here. So if you have to do a little bit of rounding there, you might be a little off of 0, but it should be like 0.1 or 0.001 or negative 0.001, you should be really, really close to 0, okay? So always use that as a check for yourself. Now you notice that the next column says you want to take x minus x bar and square it. Well, the previous column is your x minus x bar. So essentially, I'm going to take all of these answers that I have here and square them. It should be noted, you know, you're taking negatives here and you square them. Anytime you take a negative and you square it, it will come out positive. If you want to put it in your calculator for your calculator to get it right, you have to use parentheses, so negative 4.5 in parentheses squared, and that's going to give you 20.25. If it were me, I wouldn't even worry about putting the negative in my calculator, because I know that anytime I take a negative and I square it, it always comes out positive. So I would just put it in as 4.5 and square it. I'm going to try to fix that. So that would be 20.25. It's supposed to be a 25. The next one I would take negative 1.5 and square it. Again, either use parentheses or just drop the negative altogether, and that's going to give you 2.25. Negative 0.5 squared, and that's going to give you positive 0.25. 0.5 squared. If it's positive, you definitely don't need parentheses. That's going to give you 0.25. 2.5 squared is going to give you 6.25. 3.5 squared is going to give you 12.25. Lastly then, take that column and add it down. This number is always going to change on you, so if I add that down, I'd get 41.5. Now I'm ready to, I know I have all of the pieces to go to this ugly formula for standard deviation. It says it wants the sum of your x minus x bar squared. This column right here is your x minus x bar squared, and you just totaled it up, so the sum, that top number up there, is going to be 41.5. Divided by n, the number of data points. Here there were 6, minus 1. So I would really be putting my calculator, I like to do this, 41.5 divided by 5. I could type that in all at one time, and you should get 2.88. That's the standard deviation. So 2.88, I'd say, times or trips to the ATM. That's my standard deviation at the moment, okay? What you might want to do is pause the video at the moment and try example 3, because what I want to do is put both of these together and just put a nice culmination of what's going on here with the standard deviation and give you a really good picture of it. So I'm going to go ahead and fill in example 3. Example 3 here represents 6 people that go to the ATM in December. These are the number of trips that they made. Still find x bar first. You should find that whenever you add that data point, you will get 57 divided by 6. Same average, 9.5 times. So remember, this first column, take your data, subtract that average. So subtract 9.5, and it give me negative 1.5. I would continue down that column, so 9 minus 9.5, so negative 0.5. Another 9 minus 9.5, so another negative 0.5. Positive 0.5. And then 11 minus 9.5 would be 1.5. Add down. I am indeed getting 0, so I'm good to go. Take that previous column now, take all of those entries and square them. And that's going to give me 2.25. A lot of 0.25s. 1.5 squared is going to give me 2.25. Add that column down and you should get 5.5. I'm ready now for my standard deviation. Standard deviation is the square root of that 5.5 divided by n minus 1, 6 minus 1. So that would be the square root of 5.5 divided by 5, which will give me a standard deviation of 1.05 trips to the ATM. So that's my standard deviation of this time. going off of what we talked about on the previous page, what you should then be able to see is that the data down here in example 3, the December data, is much closer to the average than the November data simply because my standard deviation is a lot smaller down here. To really hit this home, I want to revisit that idea of the 5-number summary and do a box and whisker plot for November and December here on the same axis, so you can see the spread of how close and tight one set of data is versus the other. So if I come back up, to example 2, and I find my 5-number summary, remember that's just putting your data in order. So my data here, I have 5, 8, 9, 10, 12, and 13. My median is going to be right here between 9 and 10, so that's going to be 9.5. Then I can see, okay, well, this would be Q1, there's Q3, so my 5-number summary, and I'm just going to write it like this, 5-number summary then, I'm just going to list it in order, lowest data point, Q1, median, Q3, highest data point. Okay, I'm going to come down, I'm going to do the exact same thing for my December data. And so that was 8, 9, 9, 10, 10, 11. Median falls right between 9 and 10, so median is 9.5. You can easily eyeball then Q1 and Q3. And if I do my 5-number summary now for this data set, lowest data point is 8, Q1 is 9, median is 9.5, Q3 is 10, highest data point is 11. I want to take both of these data points now, for these data sets, both of these 5-number summaries, I want to take both of those now and I want to graph them on and use a box and whisker plot. So down here on my number line, I'm just going to make it a little, I'll put November up at the top. So I'll just sort of I'm going to put both of them here on the same axis. So for November, Q1 was at 8, the median was 9.5, and Q3 was 12. That formed my box. Lowest data point was 5. Highest data point was 13. And I'm just going to label this out here as November, okay? Then I'm going to come down and I'm going to say, okay, let me do December now. And so you notice from your December data, I think I can show all this on the same, there we go. From my December data, my Q1 was at 9, median 9.5, Q3 was at 10, so my box really tight right there. And my highest data point was out here at 11, lowest data point right out here at 8. Hopefully now that can really show you how down here with December, you had a smaller standard deviation at 1.05. Look how tight your data is. Versus November had a larger standard deviation, 2.88, and look at the overall spread of that data. So that's what standard deviation is telling you, how consistent your data is to the mean. And you can see down here there's a really small spread, very consistent, versus November, a lot wider scale up there. I didn't put the L's and Q1s and M's just because I didn't want to get it jumbled, but if you notice on the solution key, I did put those up there. So, I think that really should hopefully give you a good representation now of standard deviation. I'll let you, basically the subsequent pages are just designed to give you more practice. Usually the biggest thing that I'll see students forget to do is they'll go through the table beautifully, and then when they get down here, forget to take the square root. So, just be mindful and careful about things like that, and that should do it. Thanks.